let's go ahead and get started. Start off by giving you a brief overview of the history of SimpliPhi Power. So we've been producing batteries for over a dozen years now, and we are one of the longest American producers of LFP batteries. We've been doing it for 12 years, and I think many of you probably know that the move has been away from lead acid, and many different types of lithium batteries have been tried, but we've been using lithium iron phosphate since our founding in 2010. So lithium iron phosphate is a safe, non-toxic, non-hazardous battery chemistry. So instead of using rare earth metals like cobalt in our battery cathode, we're using iron, lithium iron phosphate. And so it's a safer type of battery technology. It also has a lot of other advantages. We'll talk a little bit about that, but today's talk is not really about chemistry. I want to talk to you about charge, discharge, and the state of charge of batteries, and how to interpret and understand what's happening in a battery that's discharging. But again, our batteries are safe, and that chemistry does mean that there's no real risk of thermal runaway. So those kind of battery fires that you can see when a battery is damaged, such as in the event of a car crash, etc., that's not as big of a concern with lithium iron phosphate batteries. Our batteries are UL certified for safety. We've gone through a lot of rigorous testing, safety testing on our batteries. We've developed a lot of intellectual property in this testing throughout the dozen years that we've been producing these batteries in Oxnard, California. We also have UN DOT certifications for shipping, and we can get into that a little bit more if you have questions towards the end. Our batteries are proven. We've got, like I said, over 12 years of experience now. We've grown rapidly, but also have just continued to refine and improve our batteries over the years. We're deployed in more than 45 countries worldwide. We have over 250 megawatt hours of installed batteries. It's hundreds of thousands of batteries out there that are still operating in the field. Many batteries from when we first started are still running strong. We've been tested and validated by the US Army and Marine Corps, and what that means is we were approached by them a decade ago to help them upgrade their battery systems from lead acid. However, with some of the complications surrounding cobalt-based chemistry, the Army and Marine Corps were hesitant to move towards lithium, and we were able to prove to them the safety of lithium iron phosphate batteries as opposed to cobalt-based batteries. We were deployed in Iraq and Afghanistan with the military, and so we went through a lot of testing there. Our batteries are designed to be simple to install, simple to use. We also design these batteries to be able to work with many different systems. So we're proud to have our batteries work well with other people's inverters and components. But we also have our own inverter out now, and I'll talk to you just a little bit about that. We have a SimpliPhi ESS inverter out, which is outdoor rated battery, outdoor rated inverter. It has energy track and monitoring, programming, fleet management integrated into that software that can control, do remote firmware updates, etc. We have lots of plug and play options. You can see some of those options at the bottom there. That's a Boss 12 cabinet. It's an outdoor rated cabinet. But then we also have an access cabinet, which I'll mention. And many people don't know this, but we have a whole high voltage solutions division, engineers that can design large projects for people. And so if that's something that you have in mind, talk to me at the end and I can make the right introductions for you. So as I said, this is not really a talk about battery chemistry, but I'll talk just briefly about form factor. Our batteries use lithium iron phosphate, which is the safest battery chemistry out there in terms of lithium batteries. It also is one of the longest living battery cells. Lithium iron phosphate is just a much more stable chemistry, and these batteries can last for 25 years. That's our expected lifespan of these batteries. If the batteries are treated well, 10,000 cycles can be expected. And if you're cycling once per day, that's 27 years, right? So our battery chemistry is LFP. We're not using these kind of rare earth and more toxic metals in the cathodes, so you can feel good about that. Additionally, the form factor of our batteries, form factor refers to how the individual cells that make up a battery module is made. And those cells, the cells are made with cylindrical form factor, as opposed to, there are a couple of other different types of cells that are common. There's pouch cells and prismatic cells. Pouch cells are prone to bulging. And so you might have seen these before. What I'm showing you there, that's me holding an old iPhone battery that I've taken out of an iPhone that had split apart. That's a pouch cell, right? It's the cheapest type of cell that can be made. And even a quality cell like Apple, right, with the wrong conditions, over discharge, heating, these cells can expand. Prismatic cells are also a popular choice of cell. They're cheaper than cylindrical cells to make. You can get a little bit more energy in these cells. You can make them much bigger, but they have a little bit less life expectancy. And that has to do with the fact that these cells can still swell with temperature changes. And so that expansion and contraction over time makes prismatic cells last not quite as long as the cylindrical cells. And so the cylindrical cells that we use allow us to give one of the best warranties in the industry. We have a 10-year flat-out warranty at 100% depth of discharge. And so the cylindrical cell, it's encased with a steel casing, and that prevents the cell from doing large expansions and contractions, which allows the lifetime of the cell to be much longer. It also is resistant to fire and damage, etc. And that's another reason we use it. So I'm going to go over our products so that you know what we're talking about in terms of charge and discharge. But really, this is a presentation on understanding the state of charge and how to discharge and charge your batteries safely so as not to damage them. So just a quick overview of our products. So this is our new inverter line that's out. This is a 6 kilowatt inverter, but you're capable of paralleling these up to 9 in parallel. So you can get a whole home backup out of these. They come in at a fairly good price point, and so it's become a pretty popular inverter among installers. It's outdoor rated. It still has the display built into it, even though you can program it directly off your phone through Bluetooth. These batteries are also outdoor rated. These don't need to be put in a case. They're coming at 4.9 kilowatt hours. The system is versatile, right? I was on the phone with somebody yesterday who's installing this for a small off-grid cabin. He's using older AGM batteries, but this can be used for small installations, 6 kilowatts, but all the way up to 54 kilowatts in terms of paralleling. Similarly, with his batteries, we can get up to 72 of these 5 kilowatt hour batteries. It's 358 kilowatt hours. It's a very large amount of storage. And it's a very simple system to use. The setup is quite easy. We have a 5-step commissioning process, and if you're interested, we could talk about that later. One of our most popular batteries is this Phi battery. It's a lower price point battery. It comes in both 24 and 48 volt options, 3.8 kilowatt hours, capable of charging at 75 amp hours at 48 volts, right? And it'll hold 151 amp hours at 24 volts. Same amount of power in both of those voltage variations. It's just different number of cells connected in series versus parallel. So you still get 3.8 kilowatt hours off of both of those versions. Of course, the default is moving to most people using 48 volts. It's got an integrated battery management system there to keep the cells balanced. Integrated circuit breaker is on all of our batteries to allow you to be able to turn them on and off, as well as to protect the battery from large overcurrent situations. The SimpliPhi battery has got the same kind of cell packs as the Phi battery, but it additionally has built-in closed-loop communications. It's 3.8 kilowatt hours of energy stored. This one only comes in a 48 volt version, and you get 75 amp hours of current in that battery. We recommend a max rate of discharge of C/2. However, this battery can surge at 80 amps DC. That's 4 kilowatts coming out of this battery for up to 10 minutes. Beyond 10 minutes, you would want to be drawing at a rate of C/2, so it's a little under 2 kilowatts of continuous power. Nominal voltage, that's the voltage at which the battery is at a 50% state of charge, and that's 51.2 volts DC. We've got UL 1973 certification on this module. All of our batteries are UL tested. We can talk about that if you have questions later. This battery is a little bit heavier than the Phi battery, 86 pounds. And then it's got the same dimensions, so it can fit on existing wall brackets, etc. Again, closed loop communication with the batteries and inverter allows this battery programming to be done through the communication system of the battery itself. You're limited to 72 batteries there. That has to do with the communications ports being limited in the overall length of the cable that you can have. And you can get up to 72 of these batteries to provide something around 250 kilowatt hours. It's high-level accurate readings for state of charge, voltage, charge and discharge coming from the BMS there. And these batteries will easily integrate with solar inverters, R inverters, SMA inverters, and flexible in terms of sizing, starting with a smaller building block like that 3.8. For much smaller applications and portable applications, we have some smaller batteries like this, the Phi 12 volt battery that's available, comes in 12 volt, 24 volt, 1.4 kilowatt hours there, 3/8 inch terminals, integrated BMS, of course, all of our batteries have that. We also have these product lines to make it really easy for installers. So again, I'm going to try to breeze through this quickly, but we have a partnership with Solarc, we have a partnership with Snyder, and we sell these inverters directly connected. So all the connections are basically done there for you. And so you've got a complete ESS that's UL certified, 9540 certification there. And this is a real plug and play system. It's basically as simple as putting the batteries in, tightening the lugs down and connecting it. And so it eliminates a lot of time spent doing those connections yourself if you're building up an ESS system. So I recommend these. We also have, this is called our Boss battery cabinet. We put up to 12 batteries, 12 of these SimpliPhi or Phi batteries in this Boss cabinet, which will give you 45.6 kilowatt hours. Again, outdoor rated, UL certified, all ready to go. So let's talk about charging. This is the meat of this talk today, is to make sure that everybody understands the basics of charging and discharging, and I'm happy to get into questions here. But we are recommending a C/2 charging rate for this Phi battery, and I'll be using the Phi battery, mostly the 48 volt as an example as we talk about charging and discharging. The 24 volt battery has a larger number of cells in parallel. And so basically whatever we're doing for the 48 volt, the voltages correspond. You would just divide by a factor of 2 to get that. The current rating for the 24 volt batteries is typically higher, double in fact, but we're going to use 48 volts as an example because that's what about 90% of the installs are these days. So one important thing is to remember that these batteries should only ever be paralleled in a system. We don't put these batteries in series, right? I know that people do that with lead acid batteries, but then of course, one of the challenges you can run into is having a system where your battery bank is no longer balanced, right? So only in parallel. And we're going to talk about the importance of programming, limiting charge rate on various devices. The charge controller, right, that charges up these batteries has to be set so that these batteries are not charged too quickly. The inverter, of course, the inverter charger is the same kind of thing. With an SimpliPhi battery, you have closed loop communications, and SimpliPhi can automatically populate the inverter's charge settings. AC coupled systems have further requirements, and AC coupled systems are a little harder to control, so you have to be more careful when you're setting up the charging and discharging characteristics. Basically, the AC can only be turned on and off, and it's a little bit harder to regulate. So we can talk about that. But let's go into the charging cycle of a battery. So let's suppose we start with a battery at a low state of charge. Most of you are probably familiar with this bulk absorb and float phase that is kind of a relic of the lead acid batteries. And so the battery charging cycle starts off with a constant current cycle in which the voltage changes. And then it moves into an absorb cycle, which is typically short, and the goal of the absorb cycle is to just top off the battery. And then what's not shown here is if you have a renewable energy source, you might want to just float your battery to keep it near 100% state of charge. So I'm going to talk about this cycle, and I want to make sure that everybody understands this by the end of the presentation. I figure that most of you have a brief understanding or quick understanding of this, but maybe we can get into a little bit more depth of why the voltage is varying, etc. So yesterday I was on the phone with somebody and they were asking me, what's the voltage setting, right, for the bulk cycle? The voltage varies through the bulk cycle, right? It's a constant current process of charging up the battery. So what we're going to do is we're going to set the battery to start, and we're going to set the current at which the battery is charging. So if I'm looking at just a single battery, right, that's a 75 amp hour battery, I would want to set my charging cycle to be a C/2 rating there. So a 75 amp hour battery, I'd want it to charge up in 2 hours. So if it's 75 amp hours, then I'd want it to charge at 37.5 amps, right? So if I'm charging at 37.5 amps, when I first start to charge, the voltage starts out a little bit lower, right? As the battery starts to charge, the voltage increases and increases and increases because we're trying to push the same current rate into a battery where the charge has already moved over to the cathode side, right? And so, excuse me, already moved over to the anode side. And so as we're pushing that charge, right, we have to push harder and harder, and so the voltage starts to climb. You set a top out voltage, that's your absorb voltage, and so the voltage will climb at this constant current of 37.5 amps. The voltage will climb up until it hits that absorbed voltage. That's your 56 volts DC, right? Once you're there, your battery is probably 90% charged, maybe 95% charged up. At 56 volts, we're going to set an absorb cycle, and for our batteries, it's just a 6-minute absorb cycle. And what that will do is top your batteries off. We don't want to go above 56 volts. That's where the battery is most vulnerable to damage at high states of charge and very low states of charge. So you don't want to fully discharge your battery repeatedly, and at high states of charge, you really don't want to try to put more energy into the battery than it can handle. That's when damaging is most likely going to happen. When you would use a float charge, and so typically a float charge, you'll drop the voltage even more, down to something like 53.5 volts. You would do that if you have a renewable energy source and you just want to make sure those batteries stay close to 100% state of charge in the event of, wanting backup power for an emergency. Let me go back. The rebulk voltage is the voltage. So if you start drawing this battery down, the voltage will come down, and the rebulk voltage is the voltage at which this cycle will start again. So hopefully that's clear. I'm happy to go into it if we have questions. So that's what rebulk is that the voltage as the battery is discharging, the voltage that the battery will go back into another charging cycle and start charging up again. Okay, so we want to make sure that we're using a compatible inverter that can properly limit the charge rate of the battery based on current settings, right? We want to make sure that we're not charging faster than that C/2 rating of most batteries and all of our batteries. So you have to have a compatible inverter. Some inverters are not capable of programming if they're very old, and especially some of the lead acid battery chargers, you have to make sure that they're sized properly. So you'll want to go in and make those set points as you program that inverter before you charge those batteries up for the first time. You want to get that bulk and absorb voltage setting in there. They're slightly different depending on the system that you're using. The grid charging voltage is 56 volts, right? The AC coupling absorb, again, we're at 56 volts for 6 minutes. This shouldn't say 6 minutes on the grid charging, sorry about that. You got to make sure that the manufacturer of that inverter warranties for lithium ion battery charging. If you're using external chargers, maybe you need to make sure that it's an approved charger. If you have any questions about that, feel free to message us directly. Some of these battery chargers are made for charging a cobalt-based chemistry, like the chargers that are used for bicycles, et cetera. And you want to make sure some of those don't have very advanced protections in there for charging cycles. So be careful with those. Call us. We can send you recommendations if you need them for an external charger, such as a charger that might plug into a wall socket, et cetera, for emergency charging situations. The BMS is built into the battery. It's there to shut down and sometimes protect the battery in extreme circumstances, and so that could happen. Let's talk about discharging characteristics. This is a discharge cycle for a resting battery that's an open circuit condition. And so we want to get into the variations in voltage that you see with a battery. And it does actually depend on whether the battery is powering a load or not. It does, the voltage that you'll see from your inverter or your charge controller, right, will be the inverter's voltage or the charger's voltage if you're in the middle of a charge cycle. If you're in a discharge cycle, the voltage will typically be a little bit below the battery's voltage. So this is a resting open circuit voltage. This is the voltage if I use the battery and start to discharge it and then stop the current by opening up a switch so the battery's not powering a load. This is the voltage that I would see. So at about 100% state of charge, you're a little above 53 volts. This does depend slightly on temperature. I have a slide coming up where I'll explain that. But you're about 53.2 volts when you're 100% state of charge. That's at 25 Celsius. As the battery discharges, that voltage comes down. We've got less charges on the anode side. They prefer to be on the cathode side. And so as you start to move those charges, the lithium ions from one side to the other on the battery, right? As they start, the electrons flow through your circuit, right? You discharge your battery and the voltage comes down. This is resting. So as we go, eventually when we're getting down to about 10% state of charge, there's very little energy left in the battery. And so we really recommend not going below a 20% depth of discharge if you're really trying to get the longest longevity out of your batteries. So if you're trying to get 10,000 cycles, 25 years out of your batteries, we really recommend that you set your rebulk here at about 51.8 volts, 51.7 volts. And what that'll do is keep your battery as healthy as possible, maintain a healthier battery. So let me talk briefly about what a battery looks like when it's discharging. So I've labeled a battery here as having 52.4 volts. And that's the resting voltage of that battery. That's the battery across the cell when it's not powering a load. But all batteries have some internal resistance. And so I've got just a very simple diagram here showing you that there's a 52.4 volt potential difference across the cell, but inside the cell, there is an internal resistor. So imagine if there's a current flowing out of the cell. So this is a loaded cell, not resting open circuit voltage. We're going to try to see what the voltage would look like if we were discharging the battery. So as you probably all know, Ohm's law, right? As you run a current through the resistor, there's a voltage drop across the resistor, V equals IR. So the voltage that you will actually see when a battery is discharging, even for the same state of charge. So suppose I'm at a 70% state of charge here. If you're discharging, there's also a voltage drop inside that battery, and so you'll see a lower voltage than what your resting state of charge would be. So I'm going to show you those curves. So now we're looking at discharging a battery under load. And this is why it's a little bit hard to tell the state of charge of a battery simply based on voltage. You have to know how much current is coming out of the battery. You have to know what the internal resistance of the battery is. And so this is the batteries with same states of charge, right, plotted at three different discharge rates. So a C/2 discharge rate means that a full battery would discharge itself in 2 hours. The C/3 discharge rate would be 3 hours. C/5 discharge rate would be discharged over 5 hours. And you can see that the voltage on the C/5 discharge rate is higher for the same states of charge, because the current I through the resistor is lower. If you're discharging a battery and it takes 5 hours to discharge it, right, the current coming out of the battery is smaller than if you're discharging your battery over 2-hour period. And so you'll see a lower voltage of your battery pack, but as soon as you turn the load off, they would all pop up to the same state of charge, right? So that's an important consideration, whether the battery is loaded when you're looking at the voltage of it. So if you're trying to check a battery when it's in a bank, you isolate that battery, check your voltage. That'll tell you the state of charge based on this curve that's here. Okay, I did mention, and I'm not going to talk about this much, but I did mention that the output voltage of an individual cell, right, that also depends slightly on temperature. And you see that here, if I've got a battery at 100% state of charge, right, the voltage will depend slightly on temperature. As I start to discharge that battery, if I look at a discharge of this particular battery of 1 amp hour, right, the state of charge there, you're showing about 3.25 volts. But if I'm at 0 degrees Celsius, with the same, this is an open circuit condition that, for the battery, no load, right? The voltage is actually lower on that cell, even though they're at the same state of charge. And you should never be discharging a battery at extremely low temperatures like -18 Celsius. And if you do, you'll see a much lower voltage that's almost half of a volt different when you're discharging at really low temperatures. That voltage difference tells you how much more the lithium atoms prefer to be in the cathode than the anode, and that's slightly dependent on temperature because the structure of the cathode and anode change slightly with temperature. Okay, so let's talk about the Phi battery discharging characteristics. So again, these batteries are rated to discharge at a rate of C/2. That means the capacity of the battery in 2 hours. So if you have a battery that has a 75 amp hour capacity and you're discharging at a rate of C/2, that would be our 48 volt version, right? That would be half of that battery capacity, half of that 75 amps would be 37.5 amps DC. Similarly, for our 24 volt, it actually has 150 amp hours of charge there. And if you're discharging at a rate of C/2, that would be 75 amps DC. Now that's per battery. If you have 10 batteries in a Phi bank that are all paralleled up together, you can get 375 amps out of that battery. That would be somewhere around 20 kilowatts coming out of that battery bank. And then we have smaller batteries as well. We'll talk about SimpliPhi battery considerations as well. Inverter and output limitations, we want to make sure that our inverter is not overly sized for our battery bank. SimpliPhi has got a protection on over discharge and over so rates of discharge as well as a low voltage disconnect built in. So our SimpliPhi battery is the battery with our closed loop communications. Our Phi battery is the battery. It's got an integrated BMS in it, but it doesn't have the closed loop communications. But all of these batteries are capable of surging. In fact, our SimpliPhi battery is capable of surging at 80 amps DC. Our Phi battery is capable of doing that as well, but only for 10 minutes. And you get similar surges as well. You've got both grid and residential use. These are typically used for grid-tied backup or off-grid environments. These batteries are, excuse me with that, I'm gonna have to mute this, sorry about that. Sorry for the interruption there, I forgot to mute my device. So using inline breakers for protection, this can be done, but it's not a fail-safe way of regulating charge and discharge rate. So you want to make sure that your system is sized properly. You want to make sure that your battery bank is sized to provide that output power that your inverter might draw. You want to make sure that your battery bank is sized so that it can accept the full power coming in from your solar array. We can talk about breaker location. You're going to want to have, if you're going to use a breaker in line with the battery bank, then again, you want to mount that in line with the battery bank. The battery bank is parallel, then you want to have that in line heading to the inverter. You want to have the AC output of the inverter using a breaker as well so that you're not over discharging. So breakers have they're not a fail-safe because most breakers are designed to actually trip a little bit above the amperage rating on the breaker. So here's a 60 amp DC breaker, but here's the trip area. It's showing you that it depends on the rate of current, right? So if you're at 100% rate of current, right, it actually has a time of, it has a time of, it has a decent amount of time in order to trip. And actually this breaker is going to trip at slightly above the current rating. So it's a 60 amp breaker. It looks like it might be tripping somewhere around, 70 amps or a little under 70 amps. The more the more current you're trying to pull from that breaker, the faster it will trip. But look, it's still at 150% or 140% of the capacity of that breaker. It's still taking 40 seconds to trip, right? So you can have faster tripping breakers. Here's another example of a toggle breaker, but it's giving you a wide range in terms of when it actually trips. And so these are not fail-safe ways of protecting your batteries. The best way to protect your batteries is doing it with appropriate sizing. So again, if I look at this battery and I'm at 200%, or this breaker and I'm at 200% of the rated ampacity of the breaker, right? It's going to trip somewhere between about half of a second, but all the way up to 20 seconds, right? So that's 200%. That could damage your battery if you're relying on this to protect your battery. Okay, and then there are other non-switchable versions of breakers or of fuses that you can use to protect your system. But again, you've got this range. And so keep that in mind if you're using breakers to protect your system. Let's talk a little bit about the knee. So there is a point when you're discharging a battery where there's a rapid fall off of voltage. So when we're at a 20% state of charge, the voltage as we're discharging the battery is still fairly flat. Once we get down to about 10% state of charge of the battery, what you're looking at here is voltage on the vertical curve and state of charge on the horizontal axis. So voltage on the vertical axis, state of charge on the horizontal. And what you'll see is once you get to the battery too close to fully discharged, the voltage will rapidly drop down. You never want to drop our batteries below a 48 volt cutoff. We also recommend if you want to have a long-lasting battery that you set your low battery cutoff at 50.2 volts. And so you'll set that rebulk, and so that'll go back into a charging cycle when you're down here. You don't want to go down below a 0% state of charge. You can very easily damage the battery when you do that. You also have to be careful with how heavy your loads are, depending on what the state of charge of the battery is. So the battery is most vulnerable when it's at a very low state of charge like this. So you don't want to be pulling high currents or trying to surge your battery when your battery bank is empty. So talking about state of charge then, we've got our resting state of charge where you're no longer in a state of charge or discharge. That means that the battery is not powering any loads. When you do connect a load, right, that influences the voltage that you see. And so there's this expectation of what the state of charge of the voltage of a battery should be versus state of charge. But again, that depends on temperature as well as whether or not the battery is loaded. The voltage and state of charge correlation and reading that state of charge, I hope to show you a graph on a later slide. We have battery monitors as well, and so there can be good battery monitors that maybe your system doesn't have a good battery monitor in it, and so we can recommend Victron is a good example of a company that has pretty good external battery monitors, which can be used alongside inverters, which don't have good integrated state of charge calculators. We have integration guides on our website to help you use our batteries with different equipment. And I want to say that using SimpliPhi battery for high-level state of charge readings, I mean, that's really, this SimpliPhi battery has a very advanced BMS system with closed-loop communications in there. It can both protect your battery, you can protect from low temperature conditions, but it also can give you very accurate state of charge readings directly from the battery. So again, we're talking now about the Phi battery being discharged. So this is a discharge curve, right? And it's showing the battery versus the So the different curves that are here are the rates of discharge. So again, C/5 would be discharging the battery completely over a 5-hour period, discharging over a 3-hour period for C/3, discharging over a 2-hour period for C/2. So notice that all of these, there's a kind of rapid drop off at the start. And part of that is as soon as you load a battery and you have current coming out of it, you're going to have a voltage drop due to the internal resistance of the battery. So just because you're at 52.5 volts, right, doesn't mean that your battery is highly discharged. It just means that there's a voltage drop due to the current coming out of the battery, as well as the state of charge of the battery. So that voltage drop internally will be more the faster you're discharging the battery, because V equals IR, right, where R is that internal resistance. And so when we're loading, you can get an idea of a loaded battery. So if we're max load rate, that battery, even though it's still at near 100% state of charge, we're down to 52 volts, right? A fully charged battery will start off at slightly above 53 volts, right? 53.4 or so. So don't be alarmed that as soon as you turn your loads on, right, and you're discharging this battery rapidly, that the voltage quickly drops by about a volt and a half. That's due to internal resistance causing an internal drop. If as soon as you turn the load off, that voltage will pop back up to 53 volts. Okay, so there is some correlation in terms of what the battery voltage will look like. There's programming modes of operation for getting your inverter set up so that they understand your battery bank and so that they can give you appropriate states of charge based on the voltage coming out of lithium iron phosphate batteries. Unlike the nickel and lead acid batteries, the voltage curve for a lithium iron phosphate battery is pretty flat, right? And so you don't have as much of a voltage change with LFP batteries as you do if you're familiar with lead acid batteries. So the rebulk and the recharge voltage typically will allow that battery to discharge. And if you want to have a very long-lived battery, you might set that rebulk at somewhere around 51.2 volts. That'll leave about 20 to 30% of the capacity in the battery and charge it up to around 52.8 volts, 53 volts. The generator and grid set points, we want to avoid the knee. We never want to get the battery fully discharged down to that point where the voltage drops rapidly. And if you do that, it can one, cause the battery to run a shorter life, but two, it can also, you can also just end up having your generators running far too often. So you can also set the voltages of the battery to discharge to the grid. And there are different settings based on inverter and charger companies. And so we have those built into our integration guides. So if you're installing your battery bank and using a Schneider inverter, for example, if you go to our website, we have an integration guide which provides you the inverter and charger settings based on what company you're using. So I want to talk briefly, just briefly about our Elite Installer program. So if you are an installer looking to install SimpliPhi batteries, I encourage you to sign up for our IQ Installer program. We give you $25 back, cash back per battery that you install. And so if you're installing a number of our batteries throughout the year, maybe you install something like 8 a month or something like that, we're giving you $25 as a cash back. We actually send you a check for the number of batteries that you sell. So that's one benefit of joining the IQ program, the Elite IQ program. So if you want to become a certified installer, we also will put you on our map and drive business to you. So you can see we have installers throughout the world, but people are looking to have installers local to them on the map. And so we want to get your company on the map. We also have a photo contest, and what we like to see with those photos are people, whether it's you in that photo. We of course want to see our batteries there, but we'd love to see the customers or the installers actually working on those batteries. And we have a $250 photo contest for Elite IQ members that runs monthly. So here's some examples of photos that have won our battery photo contest in the past. Again, $250 there. We roll these over too. So if we have a month where we have a few good submissions, we'll roll those over. So consider joining our Elite IQ installer program. It's pretty easy to join. You can send me an email afterwards and we can talk you through the installation process. If you've already installed SimpliPhi batteries and you have a decent idea of what you're doing, it's really easy to get approved and get into this program. So let us know if you're interested. There's a link here. Again, you'll get these slides. There's a link here to sign up for that program. But I did want to point out to you at the end of this talk that we have how-to videos on our website. We have integration guides, and what integration guides are is telling you the set points to put in. So if you're using a solar inverter and you want to know what set points to put in for the charging, discharging of our batteries, the set points, etc., click on this integrations guide. And we have integration guides for something like 7 or 8 different companies, right? For many different companies that can help you use their menus. So our tech support is willing to help you as well, even with their systems and their set points. Also have installation manuals there as well. And so I want to thank you for your time. I'm going to go into the Q&A now and try to answer any questions that you have. If you're here for NABCEP credits, please do send me an email, training@simpliphipower.com. And if you have any other questions, reach me at training@simpliphipower.com. So let me jump into the Q&A. Okay, just curious, would you equate LFP at 75% energy density compared to other formulations? How does LFP batteries stack up? Yeah, I think that's pretty close, Glenn. So to give you an idea here, LFP batteries are a little bit heavier, right? You have an iron cathode there and you don't have the cobalt. You have, the difference is that having the cobalt in the cathode makes a slightly higher voltage, right? And that higher voltage ends up meaning that you have a little bit more energy density. Now, that's not really important for home battery backup, right? But sometimes if you're trying to make a really fast, lightweight object, for example, a drone, right? You don't want that extra weight. And so I would say it's closer to 80% energy density, 75 to 80% energy density. But to talk to you about that, I mean, there's so many advantages of LFP over that cobalt-based chemistry. One advantage is that greater cycle life. Another advantage is safety, right? You just don't have that thermal runaway characteristic with LFP. So Tesla is, over half the cars produced this year by Tesla are actually switched over to LFP battery chemistry. So if it gives you an idea of how LFP wins, even with mobile devices where a little bit extra weight is unwanted, LFP has so many other advantages. And certainly for home backup and business energy backup, right? LFP is just the easy choice there. Robinson asks, please, what do I mean by C/2? So the C/2 is the charge rating of a battery. Every battery has a capacity to it, right? But there are important things to consider. So you don't want to just consider the capacity of a battery. You also have to consider how quickly you can get that energy out of the battery. So the capacity of a battery is how much energy is in the battery. The C rating of a battery is how quickly you can get that energy out of the battery, right, without damaging the battery cells. So you wouldn't want to take like a AA battery and try to get 1,000 watts out of it, right? It wouldn't make any sense. As the capacity of a battery increases, the rate at which you can get that power out of the battery also increases. So a C/2 rating really means taking the battery and being able to fully discharge that in 2 hours. So that's what a C/2 rating means. It's the current reading of the battery. It's you take the number of amp hours of the battery and divide by the number of hours that the battery is rated to discharge at. So for example, our battery's 75 amp hour battery discharged in 2 hours. This charge and discharge rating of our batteries, C/2 means 75 divided by 2 is 37.5 amps. So that's the current that you can continuously draw out of the batteries. Okay, Robinson also asked, during night period, can I use the inverter output to reconnect as input to the inverter for charging possibility of batteries. Do you mean grid? So during night, can I use the inverter output? So I'm wondering if you mean, can you use the grid to recharge the batteries? If that's the question, then the answer is yes. If I didn't answer your question, please clarify. Next question, do we have base charging minimum current for lithium batteries? We do recommend charging at a rate of at least 2 amps. But there's not really a harm in slow charging the batteries. But we recommend 2 amps or above. Most batteries designed with BMS does not work when the BMS is not connected. Can we bypass this fixture? I'm not sure what you mean there, but no, you cannot bypass the BMS. The BMS is there as the brain of the battery, but also as a safety feature of the battery. And what the BMS does is all of these batteries have a large number of cells, right? To get up to 48 volts, you have to parallel 16 LFP cells. And you also have a large number of cells in parallel. So we end up having stacks of parallel cells, and then those are stacked in series. So the BMS is there to make sure that each stack within the battery module has a balanced voltage. So you don't want to have one stack 50% discharged when another stack is only 20% discharged, right? You'll be limited by the stack that has the lowest state of charge. So the BMS is there to make sure that those stacks are balanced. Glenn asks, are simple devices available to put a temporary mobile load on all batteries in a bank to determine their condition? That I don't know, Glenn. Simple devices, yes. I mean, there are some simple devices that will give you, I mean, just a shunt is a good example of a device that will allow you to tell the state of charge by looking at that current output through the shunt, getting the voltage drop across the shunt, and having the voltage drop up, having the voltage of the battery, you could determine what the state of charge is. But shunts are really there to just keep track of the energy coming in and going out of the battery. So if that doesn't answer your question, send me an email and I'll try to clarify and I'll answer again. Barry asks, we install level 3 charger at 480 volts and 80 kilowatts. Can we power a charger with battery power? Certainly, it just depends on your inverter, right? So yes, absolutely. In fact, we get a lot of questions from from charging companies, right? Can we use your battery so we're just charging up a battery bank slowly with a renewable source like solar, right? And then we discharge quickly to rapidly charge a car, etc. So yes, you just have to size that battery bank appropriately, Barry. What exactly happens when your batteries are inadvertently overcharged? Run for the hills? Good question. No. So what happens when the batteries are overcharged? If you overcharge above 62 volts, the BMS will actually open up and prevent the battery from receiving any more charge. When you overcharge the battery, when you get an over voltage condition on the battery, you can end up heating the battery up. And so in terms of what's happening inside the cells of the battery, that extra temperature can cause degradation to the organic solvent that is what's used to hold the lithium atoms, right? So you have an organic solvent in there that holds the lithium salt. And so if you get that too hot, it can actually boil, right? And so if you are able to vaporize that, so if you get the batteries really hot, the damage would be that the batteries can off gas. So any lithium battery could off gas, but LFPs, very likely, it's very hard to catch an LFP on fire. In fact, you have to get it around 200 degrees Celsius in order to get this off-gassing thermal condition to happen. So we have some testing and we publish our testing. Mendez Martinez asks, if you have 2 5 batteries in parallel, can you charge at 37 amps times 2 at 75 amps? Absolutely, yes. And yes, we do recommend using bus bars or equal length connectors running to connection blocks, and if you're going to parallel these batteries. But yes, of course, the charge rating is scales with the number of batteries you have. So if you have 2 batteries, you would be able to go 37 times 2 or 75 amps. If you have 10 batteries, you'd be able to go at 37 amps times 10, right? 37.5 amps times 10, 375 amps. So yes, the charging rate scales with the number of batteries you have. Have you seen via battery monitor, solar charge controller let batteries get to 56.3 momentarily? Set point is 55. Okay, so Rob is just saying he's seen that battery charge controller can let the batteries get up to about 56.3 momentarily. Set point is only at 55.5, so it was unusual. Is it okay, or should the set point be lowered? I think that's okay. If it's a momentary thing, then you're not really going to have problems, Rob. Hitting a slightly high voltage is basically probably happening as the charge controller is trying to maintain that constant current bulk cycle. The batteries will then, have that voltage rise and rise and rise, and then as it switches over to the absorb cycle, it will then drop back down to whatever your set point is on absorb, which looks like 55.5. I don't think you have a problem there, Rob. Somebody asks, I am about to connect 120 kilowatt system, 3 of our Boss cabinets, 3 XW Schneiders that have 7.5 kilowatt of AC coupling. Will this be too slow of a charge? I'd have to go through the calculations with you. So you have each Boss cabinet, it sounds like each of those Boss cabinets will have about 45 kilowatt hours of storage capacity. And yeah, it's not too slow. I mean, you're charging at a rate of C/5. It just means that your system would take 5 hours to charge up. But typically, most systems have. You might be a little bit undersized if that's your solar array, but typically most locations have about 5 hours of sunlight. So I would think that you could increase the AC coupling there to more than 7.5 kilowatt hours, since you have 3 of those Boss cabinets. And I guess you were saying you have 120 kilowatt hours, not kilowatts there, but okay. Ross says, thank you. I learned a great deal from practical sizing and safe usage. Is it safe to assume all batteries are sized similarly so that 24-volt batteries have a similar power curve that drops off at from 28 to 30 volts down to 25? Yes. So Ross, if you just divide the 48-volt characteristics by 2, you'll get the 24-volt characteristics. So if you're starting off with your absorb cycle at 56, right, you would hit 28. So 30, no, you should be at the 28 and when the battery is fully charged in a resting condition, you're going to be closer to 26.5 or 27.5 volts, 27 volts, not 28 to 30, but your charging cycle, yes, if you just divide the 56 by 2, you'd be at 28 there. So 24 volt is built in a similar way, but you actually have more ampacity in the 24 volt systems. How do I recognize the damaged battery? Will all of the bank be damaged? No, sometimes you can have an individual battery damaged. And the way you could recognize that, Robert, is you could isolate the battery by disconnecting it from the system. You can turn the breaker off, or alternatively, if you have a small bank, you could turn all of the batteries off, turn your charge controller off, right? And simply measure the voltage. So that will already tell you a great deal about the health of the battery. So if that battery, if you know it's fully charged, it's gone through a full charge cycle, and you isolate it, turn its individual breaker on while having everything else off, and you're not around 53 volts, then you might have a problem with that battery, depending on the temperature slightly, right? So if you're at a temperature, a typical temperature for the battery of around 30 Celsius or so, you would expect to be about 53.4 volts at a fully charged battery. So that's one way to recognize it. Another way to recognize a battery that's damaged is if its discharge cycle just rapidly, if it just decays rapidly in the discharge cycle. So if you're using a battery and you notice that that particular battery will run very quickly, run down very quickly, then that battery likely has some cells inside that are damaged. And there are various ways that it can damage it. But if you have any questions, simply contact tech support at SimpliPhi Power. We're option number 1 on the phone tree there, and we pick up immediately. There's no hold unless we're all busy, right? But very likely you'll get straight through to somebody who won't be on hold. So happy to help you with that, Robert, if you have questions. Jimenez Martinez asked, what shunt do you recommend from Victron? So there's a battery monitor from Victron that we recommend, and I'm blanking on the model number. So if you send me an email, Martinez, I will send you a link to a very good battery monitor from Victron. Yeah, so many thousands of batteries have been installed worldwide. 250 megawatt hours of our batteries have been installed worldwide, right? So if you installed 1,000 of our batteries, you'd be looking at 4 megawatt hours. So you can figure how many tens of thousands, I guess it would be. So it looks like we're more like 50,000 batteries worldwide. So thank you for pointing that out, and I will double check it. Some of these numbers are not updated continuously either, but good point. Somebody from Haiti said this 120 kilowatt hour is out in Haiti. Great. I'm good to hear about that. I'm glad to hear about that. And if you have any questions about it, feel free to call in. We're happy to talk you through that commissioning process as well. So as you're installing those 3 boss cabinets, if you have any questions, give us a call and we'll happily walk you through it. Ross says, thanks, please send me NABCEP credit. Yeah, and he said you'll email as well. Yeah, Ross, please do email me as well, and I'll get those NABCEP credits out to you. You mentioned US DOT approval. Does this mean your batteries can be transported on cargo planes? The answer is yes. Some of the batteries have DOT certifications and UN certifications for being able to fly. It depends on which ones you're looking at. So contact our technical support and we can talk to you about which ones have those certifications for travel. What actually happens in a battery bank when the battery bank is not low or is not low and suddenly an inverter trips and quickly reconnects. This happens once or twice a day, although not frequent in an off-grid solar system at 200 kilowatts of power, kilowatt hours maybe. So Olamide, I'm not quite sure what's happening there. You might actually have a faulty breaker. So feel free to email me and give me more specifics on that, and we'll try to help you out. And yeah, so definitely any of you please do call in if you have questions. Can we get USA content documentation? Absolutely, Tim. If you send me a message, we'll send you any documentation you like. Also, we publish our safety tests. Again, this is one more person asking how you can get the NABCEP credits for this course. And you'll have to email us. So if you email us, we'll verify your participation and we will issue that certificate for NABCEP. So that's all of the questions. I want to thank you all for taking the time to be here. Looks like I have one more that came in. Per her question, a full battery shuts inverter off, but as load drains, some the inverter kicks on. Yeah, Glenn, I wasn't following that one exactly, so I think I'm going to have to answer that one offline. So thank you all, and I really appreciate the questions. They make it fun. I think they're the most fun part of the presentations here. So thank you for attending the training. Look forward to receiving more communication through email. Look out for future trainings from us as well. One more thing to point out is we're getting a lot of these trainings online at Briggs Power Academy, and you'll be able to do those at your own pace. So thank you. Have a good day, everyone.